for number 6, find the volume of the solid obtained by rotating the region bounded by y equals the square root of x and y equals x squared about the line x equals 2. Again, you have graph paper on yours, I don't, but I'll just do it without. X equals 2 is a vertical line. Kind of imagining this shape, something like this, and it's going to be going this way. So if I just give myself a first quadrant, 0, 0 is in both, 1, 1 is in both. So 0, 0, and the square root of x goes like that. So that's this function. Let's go with a different color for y equals x squared. Y equals x squared looks like that. Again, points of intersection are 0, 0, and 1, 1. And then we would highlight that region to represent the original region of the problem. The line y, or x equals 2 is the rotational axis here. So if this is x equals 1, x equals 2 would be about here. So if I'm imagining this rotational axis right here, like so, I just need to make the mirror image of this thing over on this side. So 1 away, 1 away, 2 away, 2 away, top of the leaf, bottom of the leaf. It kind of looks like that. So if I now draw, once again, a washer method this time instead of the disk method, since we're going to have a hole in it, I've got an inside radius here, and I've got an outside radius here, like so. And we always want to draw the radius back to the original region. So we can see that this is the radius of the inner circle here. And that's from the x equals 2 to the curve, that's the radius. From the y-axis to the curve is x, and from the y-axis to the axis of rotation is always however far this is, which in this case is 2. So I can see that the inner radius plus x, which is this x, I should go with blue color there, plus that x there, should equal 2. All right. This doesn't say x equals, it says y equals. So obviously if I come over here and make this say x equals plus or minus the square root of y. Well, all these x's are positive, so we're going to go x equals positive the square root of y. So for the inner radius of this thing, inner radius should equal 2 minus the square root of y. For the outer radius, same argument holds. My outer radius is right here. Just extend this green line, pretend it's not on that inside anymore. So I'm going to scribble that out, put an R right there. And now my radius is going from here to this curve here, which is the black curve. And this is still 2 here. So my outer radius plus the black x should also equal 2. But if y equals the square root of x, y squared equals x. So this is y squared, so the outer radius is going to be 2 minus y squared. So if I draw a picture of that cross section, it looks like this. I've got a black circle, outer radius of 2 minus y squared. I've got an inner circle, blue circle, that has a radius of 2 minus the square root of y, which again we like y to the half power. And my shaded in portion is in between these two circles. Pretend I'm not going outside the lines. Like so. So if I want to find the area of the cross section, I just take the black circle minus the blue circle. So it's going to be pi times 2 minus y squared squared minus pi times 2 minus y to the 1/2 squared. Then we just work it out. So we've got pi times 4 minus 4y squared plus y to the 4th minus pi times 4 minus 4y to the 1/2 plus y to the first. Distribute the pi's through, combine like terms. I'm going to get a 4 pi minus 4 pi y squared plus pi y to the fourth minus 4 pi plus 4 pi y to the half minus pi y. 4 pi minus 4 pi cancels. No like terms beyond that. So my volume simply becomes pi integral of all this stuff without the pi. So negative 4y squared plus y to the fourth plus 4y to the half minus y. dy. And my circles are starting at 0 and ending at 1. So the circles are moving vertically this time. Y equals 0 is the bottom, y equals 1 is the top. So 0 to 1 is my interval. So again, construct the integral, then work the integral out. Once again, it's a power rule scenario. So negative 4y squared becomes negative 4y cubed over 3. Y to the fourth becomes plus y to the fifth over 5. 4y to the half becomes 4y to the 3 halves over 3 halves, which is times 2/3. And then y is y squared over 2, going from 0 to 1. I'm going to change this to that way so I can write easier. That is really sloppy. Here we go. So if I put 1 in, I'm going to get a bunch of values. If I put 0 in, I'm going to get a bunch of zeros. So at this point, if I just put 1 in, I got pi. 1 cubed, 1 to the fifth, 1 to the 3 halves, 1 squared, all equals 1. So I'm just going to get negative 4/3 plus 1/5 plus 8/3 minus 1/2. Again, put in a bunch of zeros, you're going to get zeros. Common denominator there looks like to be 30. So I'm going to make my common denominator 30. Times 10 makes negative 40. Times 6 makes plus 6. Times 10 makes plus 80. Times 15 makes minus 15. So 86 minus 55 is 31. 31 pi over 30 is the volume of that one.